Okay, so this video today is to help you with your assignment that's due on Friday this week. I regenerated the worksheet, and there's a copy of it on Canvas for you. It says like version 2. Version 2 is not your homework. Version 1 was your homework. The original one you were given was your homework, but what I did was I made another version so I could do some new problems that might be like your homework problems. So let's start. My first problem on my new worksheet says root 3 cosine theta minus 3 tan theta equals cosine theta tan theta minus 3 tan theta. So I'm going to move everything to one side and combine like terms. So I'm going to add my 3 tangent theta over and add my 3 tangent theta over. So I have root 3 cosine theta equals a cosine theta tangent theta. I'm going to put everything on one side. It's never a good idea to divide by a trig function because when you do, you cancel out answers. So rule of thumb, don't divide by a trig function. Just put them on one side so maybe you can do some other kind of math. So I'm going to subtract the cosine theta tangent theta over to the other side. Now both of my terms have a cosine in them. So I'm going to pull out or factor out the cosine. I'm left with a root 3 minus a tangent theta, and it equals 0. Now I have two pieces. I have this green piece and this red piece, and they are multiplied together. And since they are multiplied together, I can use what's called the zero product property. I can set each piece equal to 0. Zero product property, let me go back for a second. If you have A times B equals 0, then one of these things, A has to equal 0, or B has to equal 0, one or the other. Maybe both. So my A in this case is my cosine theta equals 0. And then I have my root 3 minus tangent theta equals 0. Keep in mind, you can only do this when it equals 0, which is why I moved everything over to one side. So for this piece, it says from 0 to 2 pi. So on this problem, this happens, cosine equals 0 at pi over 2 and 3 pi over 2. On this problem, I'm going to minus a root 3 minus a root 3, so I get negative tangent theta equals negative root 3. Then I'm going to divide by a negative, so I get tangent theta equals root 3. Well, for this one, theta equals pi over 3 and at 4 pi over 3. So these two are answers as well as these two. So there's all of my answers for this problem. Okay, I'm going to do another one. So let's try number 4. So I have 4 sine theta plus 2 equals 4 sine squared theta plus 3. This is definitely a quadratic, and I know that because I have a trig function squared, and I have the same trig function not squared, so this screams quadratic. So I'm going to move everything over to one side. So I'm going to have, oops, that's a highlighter, hang on. So on this one, I'm going to move the 4 sine and the 2 over. So I'm going to have 0 equals 4 sine squared theta minus the 4 sine theta I moved over. And I'm going to minus my 2 and minus my 2, so I get plus 1. And I picked this problem because I'm not sure we all love factoring, but we're going to try it. So I do an A times C method, so A times C. 4 times 1 is 4. I need two factors of 4 that add and give me negative 2. So how about negative 2 and negative 2? A negative 2 times a negative 2 is a positive 4, and a negative 2 plus a negative 2 makes a negative 4. So I'm going to rewrite that middle term. I'm going to keep my 4 sine squared theta. Instead of writing negative 4 sine, negative 2 sine theta minus 2 sine theta plus 1. I've done this in a previous video, but let's do it again. And I can now have factor by grouping. Here's a group right here, a red group, and a blue group. So in my red group, they have a 2 sine in common. I'm left with a 2 sine theta minus a 1. In my blue group, they have a minus 1 in common. I'm left with 2 sine theta minus 1. So the reason I like factor by grouping over box method is because the thing in my parentheses right here and right here has to match if you did it right. And I did. So now what I'm going to do is I'm going to pull that green underlined thing out of both groups. So I have 2 sine theta minus 1 equals, and then I also on the not equal, sorry. I pulled my 2 sine theta out of both groups, and I'm left with this 2 sine theta right here, and then the minus 1 right here. So we set each piece equal to 0, and in this case, our pieces are the same, so I only have to do it once. Add a 1 and divide by 2. So where does sine equal a half? Sine equals a half at pi over 6 and at 5 pi over 6. I know how much you guys love factoring. It's your best friend. Ooh, let's do number 6 because I don't want you to forget about a plus and minus sign. So let's do number 6. So number 6 on my set of problems says 0 equals negative sine squared x plus 1 minus 1 minus 1. So negative 1 equals negative sine squared theta. Divide by negative 1, divide by negative 1. So 1 equals sine squared theta. To take care of the square, I need to square root both sides, and this is where you have to be careful. You're putting a square root on the paper. The square root of 1 is not just 1. The square root of 1 is plus and minus 1. So make sure if you put a new square root on the paper that you put the plus and minus. So plus and minus 1 equals sine theta. The theta where sine equals 1 is pi over 2. And the theta where sine equals negative 1 is 3 pi over 2. So both of these, not one, not the other, but both of them is my answer. Okay, let's see. I'm just going for another problem to do really quick, so bear with me for a second. Let's try... let's see. Let's try number 11. So number 11 on my page says cosine. So I have cosine of theta plus 2 pi over 3 equals a half. So I'm going to use a fancy letter. It's called alpha. It's just a Greek letter. I'm going to use alpha for a second. I'm going to call this whole angle thing alpha. So when I do that, I get cosine of alpha equals a half. So that means alpha equals, where does cosine equal a half? That happens at pi over 3 and at 5 pi over 3. But I did not have alphas. I definitely had a theta plus 2 pi over 3. So to solve for theta, I'm going to subtract my 2 pi over 3 and subtract a 2 pi over 3. I want to make one note right here. Be careful. The circle in theory keeps going. So if I have an answer at pi over 3 right here, that's pi over 3. But I could go the whole circle and then there, and that would have been 7 pi over 3. And while this yellow one is outside my restriction, it may not be in a second when I take care of this subtraction piece right here. So here's what I'm going to do. I'm going to do my pi over 3 minus my 2 pi over 3. That's negative pi over 3. Then I'm going to do my 5 pi over 3 minus 2 pi over 3, which gets me 3 pi over 3, or just a pi. And then I'm going to check this last one right here. So 7 pi over 3 minus 2 pi over 3 makes a 5 pi over 3. So this is where we check our restrictions. The problem, the directions, it said from 0 to 2 pi. Well, this answer right here is not an answer because negative pi over 3 is not within my answer. So that leaves me these two as my answers, pi and 5 pi over 3. So those were my answers for this problem. Let's try number 13. So number 13, I have negative 1 equals negative 2 minus cosecant theta over 3. So I'm going to add my 2 and add my 2. So 1 equals negative cosecant theta over 3. divide by negative 1. So negative 1 equals cosecant theta over 3. So I'm going to just, again, call this whole thing alpha for a second. Where does cosecant equal negative 1? Well, that's the same thing as saying negative 1 equals 1 over sine alpha. You can cross multiply and resolve, but you should get that negative 1 equals sine of alpha. So that means that my alpha is equal to the place where sine equals negative 1, which is 3 pi over 2. But I did not have an alpha. I had a theta over 3 equals 3 pi over 2. So now what I'm going to do is I'm going to multiply by 3 on both sides to undo this. Multiply by 3. And so I get theta equals 9 pi over 2, which is equal to 4.5. So 4... It's 4 whole pi's and another pi over 2 left over. But that is not between my 0 and 2 pi. So this problem has no solutions because this answer that I got does not fit within that restriction. So hopefully this video helps you a little bit. I lied. Let's do one last problem. I'll do number 14 because it's got 2 combinations in it.